All right, so we're going to look at we're going to take what we talked about the other day in that last video on conditional statements, and we're going to take it a step further. We're going to decide if those statements are true or false, and that really is what gets into the math section in the mathematical way of thinking, is deciding if they're true or false. Because just writing those statements, that's kind of a very simple type thing. But now we want to go a little bit further and start seeing whether or not we understand those statements. So we're going to decide whether something's true or false. Now in math, just because something is true or false doesn't necessarily coincide with what you would think normally has happened. In a math statement, it's true only if it's true for every possible case. If you can think of one thing that makes it not true, then it's false. It's kind of a weird thought process, but we'll start working through it. Okay, so in this first statement, we can say that a statement is true if the conclusion follows for all cases that fulfill the hypothesis. So I can change up the conclusion over and over and over and over again, but as long as it fulfills that hypothesis, then we're good. A statement's false if you can find one example in which the hypothesis is fulfilled and the conclusion is not. I think it's easier to go through and decide whether or not a statement's false or not, because if you can't come up with a reason that makes it false, then it's true. So I would try to decide whether or not the statement is false first. And anytime that we're able to change up that conclusion, that's called a counterexample. Okay, so let's look at a couple of examples, and we're just going to go through two right now. I don't want to make this video too long, so we'll talk about a little bit more later on. But for right now, we'll just do two quick examples. All right, so it says, if two lines never touch, then they are parallel. Well, if you think back to one of the vocabulary terms that we talked about before, we've talked about something called skew lines. And so skew lines never touch, but they're not parallel. So this statement would actually be false. Okay, because if two lines never touch, that's our hypothesis. If two lines never touch, the conclusion would be then they're parallel. I could also replace parallel with skew lines, and it would be a true statement. So this statement overall is false because I can come up with a counterexample. That's why I think it's kind of easier to come up with, decide whether or not it's false other than when it's true. Okay, so let's look at the converse. If two lines are parallel, then they never touch. Well, there's no counterexample, because if lines are parallel, they will never touch. So this statement would be true because we cannot change the conclusion to do anything. And I would never change the hypothesis. So you would never say if two lines are perpendicular, then they never touch. Well, you can't do that. Whenever we're deciding whether it's true or false, we leave the hypothesis the same and only mess with the conclusion. Okay, so that first one, we could change parallel to skew lines and still have a statement that is technically correct. So that means that the original is false. I know it's kind of out there. It's kind of a weird topic, but those of you that are very creative and off-the-wall type thinkers, you ought to love this section. I know I enjoy it a lot, but it's something that we'll work on, and we'll spend some time going through and doing. All right, now the last thing I want to talk about, we talked about what conditional statements are. We talked about whether something's true or false. There's one last type of statement that we need to talk about, and it's just called a biconditional statement. This is very similar to conditional, except that notice that by in there, that means two. So it's like it's a combination of two conditional statements. All right, so what that means is the hypothesis is true if and only if the conclusion is true. And notice you have that if and only if. That's what makes it a biconditional statement. And then for the symbols, P again is the hypothesis, Q is the conclusion. You'd have if and only if. And notice our little symbol right here, there's arrows on both sides because they both have to be true. All right, so let's look at two quick examples, and then that's it. An example of a biconditional statement would be an angle is right if and only if. Notice it's not if first, not in a biconditional. So an angle is right if and only if it measures 90 degrees. And finally, another example would be it measures 90 degrees if and only if it is a right angle. Okay, so that would be an example of a biconditional statement. All right, now that's it for these examples. Again, we'll talk more about true-false statements in class. And so if you're a little bit confused by those, we're going to do some more examples and kind of go a little bit more into depth when we get into class.